In this video, we are going to talk about the postulate 4 of quantum mechanics. Fourth postulate. Postulate 4 of quantum mechanics. Okay. The postulate 4 of quantum mechanics says that the expected average value of a physical quantity of a system whose state function psi is defined by the expected, let me write it here, the expected average value of a physical quantity of a physical physical quantity. Okay, this is also called expectation value. Expectation value, or the expected average value of a physical quantity of a system of a system is a system whose state function whose state function is psi is given by is given by is given by integral m bar is equal to integral psi star m cap psi d tau divided by integral psi star psi d tau. Okay, this is the fourth postulate of quantum mechanics. The expected average value of a physical quantity or expectation value of a system whose state function psi is given by m bar is equal to integral psi star m cap psi d tau divided by integral psi star psi d tau. What does it mean? We have a system, a microscopic system, and we want to measure some physical quantity of this one. For example, we wanted to measure the energy of the system, okay, the total energy of the system. So if we measure the total energy of the system, we want to use the operator H cap or Hamiltonian operator, because that is the operator corresponding to total energy, right? So we want to measure the total energy of the system, and each time when we are measuring the total energy of the system, we may be getting some value, some allowed value for that total energy. And the average of this total energy will be given by m bar is equal to integral psi star m cap psi d tau divided by integral psi star psi d tau. This is the meaning of the postulate. Okay, the expected average value of a physical quantity, and that is also called expectation value of a system whose state function is psi is given by m bar. M bar is equal to integral psi star m cap psi is equal psi d tau divided by integral psi star psi d tau. Okay, so we have some prior knowledge of the state function of the system, and we also want to know which physical quantity we want to measure, and corresponding to that there is a quantum mechanical operator, we know that. And if we know this, we can get the expectation value of that physical quantity from this equation. Okay, this is the fourth postulate of the quantum mechanics. Okay, so let us let us analyze this equation further. And now let us suppose that psi is normalized. Okay, psi is normalized. If psi is normalized, if psi is normalized, then you know that it means that integral psi star psi d tau is equal to 1, right? That is the meaning of normalized psi. Then m bar in that case is equal to integral psi star m cap psi d tau, because the denominator is equal to 1. So this is the case if psi is normalized. We know that in quantum mechanics, if you have a state function, that state function will be normalized or normalizable, right? If it is normalizable, we can multiply that state function with some constant so that it will be normalized after that. Okay, so in most of the cases, we will be satisfied by this expression because I will be normalized. The state function that we are deriving will be normalized or normalizable. So at the end, anyway, we will have some normalized function. So this is okay. M bar is equal to integral psi star m cap psi ditto. Okay, and now we can see if psi is an eigenfunction of m cap. Okay, this is what we considered first, and now we are considering if psi is an eigenfunction eigenfunction of m cap. What is m cap? M cap is the operator corresponding to some physical quantity m. Okay, we are measuring some physical quantity m. The m bar is the operator corresponding to that. So if psi is an eigenfunction of m cap, okay, then we can write m cap psi is equal to m psi. You can write m cap psi is equal to m psi, where small m is the value of this physical quantity. This physical quantity was just represented by m. Let it be energy, then small m is the energy value. If it is angular momentum, small m is the angular momentum value. So m cap psi is equal to m psi. So then we can say that psi is an eigenfunction of m cap. Okay, and in that case m bar is equal to, assuming that psi is already normalized, m bar is equal to, so we are going to use this equation. M bar is equal to integral psi star m cap psi. M cap psi is equal to m psi ditto, or we can write m integral psi star psi ditto, and that is uh, equal to m, because psi star ditto is equal to 1 because psi is already normalized. Okay, so if psi is an eigenfunction of m cap, provided psi is normalized, then m bar will give the eigenvalue m. Okay, so what does it mean? If you are using this postulate for equation, okay, the expectation value equation for an eigenfunction, then we will get the eigenvalue. Okay, we will readily get the eigenvalue. Okay, and now we are supposing that if psi is not an eigenfunction, okay, we are considering the case where psi is not an eigenfunction. Suppose psi is not an eigenfunction. Psi is not an eigenfunction of m cap. Okay, psi is not an eigenfunction of m cap, and at the same time, we know that m cap has some other set of eigenfunctions. Okay, for example, m cap has a set of eigenfunctions, eigenfunctions, which are phi 1, phi 1, phi 2, phi 3, okay, etc. These are the eigenfunctions of m cap. Okay, so be very careful. Psi is not an eigenfunction of m cap, but at the same time, m cap has a set of eigenfunction phi 1, phi 2, phi 3, etc. And there is another feature with this phi 1, phi 2, phi 3, etc. These are orthonormal set. Orthonormal set. Have you heard about orthonormal set? Orthonormal set means a set of functions. Okay, a set of functions are said to be orthonormal if integral phi I, okay, phi I star phi I ditto is equal to 1. Okay, then we can say that each phi I is normalized. Okay, and at the same time, if integral phi I star phi j ditto is equal to 0, then we can say that phi I and phi j are orthogonal. Okay, So in this case, we say that they are normalized. In this case, normalized. And in this case, it is orthogonal. Okay, orthogonal. So a set of functions are said to be orthonormal if each one of them are normalized and at the same time they are orthogonal to each other. Okay, each one of them are normalized means phi1 is a normalized function, phi2 is another normalized function, phi3 is another normalized function. So that all the functions in this set are normalized, but at the same time they are orthogonal to each other. Means if you are taking integral phi1 phi2 dito, then it will be 0, or integral phi2 phi3 dito, it will be 0, or integral phi1 phi4 dito, it will be 0. So all these are all these functions in this set are orthogonal to each other, and such a set is called orthonormal set. So we have an orthonormal set phi1, phi2, phi3, etc. Okay, and in this orthonormal set, each function is an eigenfunction of the operator m cap. Okay, in that case, if this is the case, then we can write psi. Okay, psi you already know, psi is not an eigenfunction of n cap, but psi is a state function. Okay, psi is a state function of the system that we are considering, but at the same time that is not an eigenfunction of n cap. Therefore, in that case, we can represent a psi as a linear combination of these orthonormal functions. Means a1 phi 1 plus a2 phi 2 plus a3 phi 3 plus etc. Okay, so in that case we can represent the eigenfunction psi as a linear combination of the functions phi 1 phi 2 phi 3 etc. Okay, so in otherwise we can write psi is equal to sigma I a I phi I. Okay, so this is very general procedure in quantum mechanics. You do not have an eigenfunction, but at the same time you can express this function as a linear combination of a set of eigenfunctions. Okay, and these eigenfunctions are orthonormal functions, and these are eigenfunctions means what? Phi 1, phi 2, phi 3, etc. are eigenfunctions. It means what? They can be written in the form like m bar, okay, m cap phi 1 is equal to lambda 1 phi 1, okay, or m cap phi 2 is equal to lambda 2 phi 2, etc. We can write it like this. That is why we call this phi 1 phi 2 etc. are eigenfunctions of m cap. Okay, anyway, now we know that psi is the sigma I ai phi I, sigma I ai phi I. Okay, now let us substitute this value of psi as sigma ai phi I in our expectation value equation. Therefore, m bar from the fourth postulate we have m bar is equal to integral psi star m cap psi dito, m cap psi dito if psi is normalized. Okay, now if psi is normalized, so we can write it like integral. What is psi? Psi is equal to sigma I ai phi I. So let me write like sigma I ai phi I. Okay, star m cap psi, that is equal to sigma I ai phi I dito. Okay, that is equal to m bar. Okay, so I can write it like sigma I sigma j um, ai star aj integral phi I star m cap phi j dito. Okay, are you confused here? Okay, I will explain why I have written like this. So this is equal to sigma I sigma j a star aj integral phi I star m cap phi j dito. What I have done here, sigma only shows the summation. Okay, summation of this type of terms a1 51 plus a2 52 plus a3 53 എന്നുള്ളതാണ് സിഗ്മ കാണിക്കുന്നത്. ഓക്കെ, അപ്പോൾ ഈ ഐക്ക് ഓരോ വാല്യൂ കിട്ടുന്നു, 1 2 3 എക്സെട്ര എന്ന് പറയുന്ന ഓരോ വാല്യൂ ഐക്ക് നമ്മൾ അസ്യൂം ചെയ്യുന്നു. അതാണ് ഇവിടെ ചെയ്യുന്നത്. അപ്പം നമ്മൾ ഇവിടെ നോക്കുക, നിങ്ങൾ നോക്കുക, ഞാനൊരു ചെറിയ ഒരു ഫംഗ്ഷൻ ഇങ്ങോട്ടൊന്ന് എഴുതി കാണിക്കാം. അപ്പം നമ്മൾ എങ്ങനെ ചെയ്യുന്നത്, ഇപ്പം ഈ എ സിഗ്മ എ ഫൈ എ എന്നുള്ളതിന് പകരം ഞാൻ a1 51 പ്ലസ് a2 52 ഓക്കെ പ്ലസ് a3 53 എന്ന് അസ്യൂം ചെയ്യുക. ഓക്കെ, അങ്ങനെയാണെന്നുണ്ടെങ്കിൽ അപ്പം നമുക്ക് എങ്ങനെ എഴുതാം, a1 51 ഇപ്പം സിഗ്മ എ ഫൈ ഐ സ്റ്റാർ എന്നുള്ളതിന് പകരം നമുക്ക് ഇങ്ങനെ എഴുതാം a1 51 പ്ലസ് a2 52 plus a3 53 star. Okay, then it is multiplied with m cap again sigma a means a1 51 plus a2 52 plus a3 53. Okay, ഇങ്ങനെയാണ് നമുക്ക് എഴുതാവുന്നത് അല്ലേ. സോ വി ക്യാൻ റൈറ്റ് ഇറ്റ് ലൈക്ക്, ഇപ്പം നമ്മൾ ഇവിടെ എന്താ ചെയ്യുന്നത്, ഇവിടുത്തെ ഓരോ ടേമും എടുക്കുക. a1 51 എന്നുള്ളതാണ് ഫസ്റ്റ് ടേം. Then it is multiplied with m cap a151. Then a151 is multiplied with m cap a252. Then a151 multiplied with m cap a353. അല്ലേ, അങ്ങനെയാണ് ചെയ്യുന്നത്. അപ്പം നമ്മൾ അങ്ങനെ ചെയ്യുമ്പോൾ നോക്കിയോളൂ, നമുക്ക് എങ്ങനെ കിട്ടുന്നത് a1, ഇപ്പം ഞാൻ കുറച്ച് ടേമുകൾ എഴുതി കാണിക്കാം. a1 then 51 then m cap 51. നമുക്കൊരു ഇൻ്റഗ്രൽ സൈൻ കൂടി ഉണ്ടായിരുന്നു, ഞാൻ അതും കൂടെ ഇവിടെ ഇട്ടിട്ടില്ല, അതുകൊണ്ട് നമ്മൾ ഇട്ട് പോകുന്നതായിരിക്കും നമുക്ക് നല്ലത്. ഒരു ഇൻ്റഗ്രൽ സൈൻ കൂടി കൊടുക്കുക, അങ്ങനെയാണ് നമുക്ക് ഇവിടെ ഇൻ്റഗ്രൽ സൈൻ കൂടി ഉൾപ്പെടുത്താം. a1 51 m cap 51 പ്ലസ് പിന്നെന്താണ് വരുന്നത് a1 പിന്നെ ഇവിടുത്തെ a2 ആണ് വരുന്നത് അല്ലേ, a1 a2 ഇൻ്റഗ്രൽ 51 m cap 52. ഓക്കെ, 52 ഡീറ്റോ ഉണ്ട് ഇവിടെ, ഇൻ്റഗ്രേഷൻ നമ്പർ ഡീറ്റോ പ്ലസ് പിന്നെന്താണ് വരുന്നത് a1 a3 ഇൻ്റഗ്രൽ 51 m cap 53 ഡീറ്റോ പ്ലസ് എക്സെട്ര, ഇങ്ങനെ പോകും. പിന്നെ നമ്മൾ ഇവിടുന്ന് a2 എടുക്കണം, a2 a1 അങ്ങനെ ഓരോന്നെടുത്ത് പോകണം അല്ലേ. അങ്ങനെ നമ്മൾ ഓരോ ടേമുകളെയും ഈ 3 എണ്ണം കൊണ്ടും ചെയ്യണം. അപ്പോൾ ടോട്ടലി നമുക്കൊരു 9 ടേംസ് കാണും. അപ്പം നിങ്ങളിവിടെ നോക്കുക, ഓരോ ടേമിലും എങ്ങനെ ഇരിക്കുന്നത്, ഇവിടെയാണെങ്കിൽ a1 രണ്ടാമത്തെ ടേബിളാണെങ്കിൽ a1 a2, മൂന്നാമത്തെ ടേബിൾ a1 a3, നാലാമത്തെ ടേം വരുമ്പോൾ എങ്ങനെയായിരിക്കും a2 a1 പിന്നെ a2 a3 പിന്നെ a3 a1 a3 a2 a3 അങ്ങനെയാണ് വരുന്നത് അല്ലേ. അപ്പം നമ്മൾ ഇവിടെയുള്ള 1 ഉം 2 ഉം ഇവിടെ 1 ഉം 1 ഉം ആണ്, ഇവിടെ ആകുമ്പോൾ 1 2 ആവും, ഇവിടെ 1 ഉം 3 ആയി അങ്ങനെ മാറുന്നുണ്ട്. അത് കാണിക്കാൻ വേണ്ടിയാണ് ai aj എന്ന് കൊടുത്തിരിക്കുന്നത് ഇവിടെ കേട്ടോ. അപ്പം ഈ ഐക്കും ജെയ്ക്കും ഇവിടെ ഈ പർട്ടിക്കുലർ കേസിൽ 1 to 3 വരെയുള്ള എല്ലാ വാല്യൂസും പോസിബിൾ ആണ്. ഐ ആയാലും ജെ ആയാലും ഈ പർട്ടിക്കുലർ എക്സാമ്പിളിൽ നമ്മൾ വെറുതെ കൊടുത്തിരിക്കുകയാണ്, ഒരു എക്സാമ്പിൾ കാണിച്ചു എന്നേ ഉള്ളൂ. ഈ പർട്ടിക്കുലർ എക്സാമ്പിളിൽ 1 to 3 വരെ ഉള്ള എല്ലാ വാല്യൂസും പോസിബിൾ ആണ്. ഓക്കെ, അപ്പോൾ ഡസൻറ്റ് മാറ്റർ വെദർ ഇറ്റ് ഈസ് ഐ ഓർ ജെ, ഓൾ പോസിബിൾ വാല്യൂസ് ആർ ദെയർ. ഓക്കെ, അതുകൊണ്ടാണ് ഇതിനെ സിഗ്മ ഐ സിഗ്മ ജെ എ ഐ സ്റ്റാർ എ ജെ ഇൻ്റഗ്രൽ 5i സ്റ്റാർ m cap 5j ഇട്ട് വന്നിരിക്കുന്നത്. അതിന് പകരം നമ്മൾ ഇവിടെ നിന്ന് നേരെ ഇൻ്റഗ്രൽ 5i സ്റ്റാർ 5i സ്റ്റാർ m cap 5i എന്നാ ഉപയോഗിച്ചിരിക്കുമോ, ഐക്ക് പകരം ജെക്ക് പകരം ഐ തന്നെയാണ് ഉപയോഗിച്ചിരിച്ചു രണ്ട് ടേമുകളും. അങ്ങനെയാണെന്നുണ്ടെങ്കിൽ ചില ടേമുകൾ മാത്രമേ പോസിബിൾ ആയിട്ടുള്ളൂ. ഏതൊക്കെയാ, a1 വരുന്നത് പോസിബിൾ ആവും, പക്ഷേ a1 a2 വരുന്നത് പോസിബിൾ ആവുമോ, ഐയും രണ്ടും ഐ ഇട്ട് കഴിഞ്ഞാൽ a1 a2 എന്ന് പറയുന്ന ടേമിനെ നമ്മൾ എക്സ്ക്ലൂഡ് ചെയ്ത് കളയും അല്ലേ, അത് ഇൻക്ലൂഡഡ് ആവത്തില്ല. അപ്പോൾ എല്ലാ ടേമുകളെയും ഇൻക്ലൂഡ് ചെയ്യിക്കാൻ വേണ്ടിയാണ് ഐയും ജെയും കൊടുത്തിരിക്കുന്നത്. ഓക്കെ, ഐ ഹോപ്പ് യു അണ്ടർസ്റ്റുഡ് what is meant by this line. So sigma I sigma j ai star aj integral 5i star m cap 5j d2. Okay, now where you know that where I is equal to j and I not equal to j are possible. രണ്ടും ഇവിടെ പോസിബിൾ ആണ് കേട്ടോ. ഐ ഒന്നുകിൽ ഐ ഈസിക്കൽ ടു ജെ ആകാം, ഐ അല്ലെങ്കിൽ ഐ നോട്ട് ഈക്വൽ ടു ജെ ആകാം, എല്ലാ വാല്യൂസും പോസിബിൾ ആണ്. അങ്ങനെയുള്ളൊരു ഇക്വേഷനാണ് നമ്മൾ എഴുതിയിരിക്കുന്നത്. ഓക്കെ, സോ now let us rearrange this equation like m bar is equal to sigma i sigma j ai star aj, okay, integral phi I star m cap phi j. What is m cap phi j? m cap phi j is equal to lambda j phi j അല്ലേ? m cap phi j എന്ന് പറയാൻ lambda j phi j ആണ്. കാരണം എന്താണ്, നമ്മൾ കൊടുത്തിട്ടുണ്ട് m cap phi 1 is equal to lambda 1 phi 1, m cap phi 2 is equal to lambda 2 phi 2. Therefore m cap phi j is equal to lambda j phi j. So let us substitute for m cap phi j here. So m cap phi j is equal to lambda j phi j then d tau. Okay, that is equal to sigma j ai star aj, then lambda j is a constant, so we can take it out of the integral sign. So let me write lambda j integral phi I star phi j d tau. Okay, so that is equal to, now we have to look into this expression. We have an integral phi I star phi j d tau, integral phi I star phi j d tau. See, we had a condition that the set is the phi 1 phi 2 phi 3 etc set is orthonormal set, means integral phi I star phi j d tau is equal to 1 and integral phi I star phi j d tau is equal to 0 അല്ലേ? എങ്ങനെയാകുമ്പോഴാ integral phi I star phi I d tau is equal to 1 and integral phi I star phi j d tau is equal to 0. അതായത് ഓരോന്നും നോർമലൈസ്ഡ് ആണ്, എന്നാൽ ഓരോ രണ്ടെണ്ണം നമ്മൾ എടുത്തു കഴിഞ്ഞാൽ ഓരോന്നും അങ്ങോട്ടും ഇങ്ങോട്ടും ഓർത്തോഗോണലുമാണ് അല്ലേ? അപ്പൊ I is equal to j ആവുന്ന കേസുകളിലെല്ലാം, അതായത് രണ്ടും I ആണെന്നുണ്ടെങ്കിൽ അവിടെ അത് ആ ഇന്റഗ്രലിന്റെ വാല്യൂ എത്ര ആയിരിക്കും? 1 ആയിരിക്കും. പക്ഷെ I നോട്ട് ഈക്വൽ ടു j ആണെന്നുണ്ടെങ്കിലോ എന്തായിരിക്കും? അത് 0 ആയിരിക്കും. അപ്പോൾ ഇതൊരു ഓർത്തോനോർമൽ സെറ്റ് ആയതുകൊണ്ട്, സിൻസ് ഇറ്റ് ഈസ് ആൻ ഓർത്തോനോർമൽ സെറ്റ്, this integral, okay, will be equal to 1. Integral phi I phi j d tau is equal to 1 if I is equal to j, because it is normalized. Okay, and we also know that integral phi I phi j d tau is equal to 0 if I not equal to j, because they are orthogonal. Okay, അപ്പം നമ്മുടെ ഈ ഇന്റഗ്രലിനകത്ത് എല്ലാ ഇന്റഗ്രൽസും എക്സിസ്റ്റ് ചെയ്തില്ല, ചില ഇന്റഗ്രൽസ് എല്ലാം 0 ആയി പോകും. ഏതൊക്കെ ഇന്റഗ്രൽസ് 0 ആയി പോകുന്നത്? whenever I not equal to j, those integrals will be 0. Therefore only those terms will exist where I is equal to j. I j ആവുന്ന ടേംസ് മാത്രമേ എക്സിസ്റ്റ് ചെയ്യത്തുള്ളൂ. Therefore how we can write m bar is equal to sigma I അല്ലേ? പിന്നെ സിഗ്മ j കൊടുക്കേണ്ട ആവശ്യമില്ല, because j is already equal to I. ഓക്കെ, ജെയും ഐയും ഒന്നാവുന്ന കേസിൽ മാത്രമേ എക്സിസ്റ്റ് ചെയ്യത്തുള്ളൂ, അതായത് ജെയും ഐയും ഒരേ വാല്യൂ ആണെങ്കിൽ മാത്രമേ ആ ടേം എക്സിസ്റ്റ് ചെയ്യത്തുള്ളൂ. സോ ഇപ്പോൾ വി ക്യാൻ റൈറ്റ് സിഗ്മ I ai star instead of aj we can write ai, because I is equal to j. Then we can write lambda I integral phi I star phi I d tau, right? So that is equal to sigma I ai star ai lambda I, because integral phi I star phi I d tau is equal to 1. Okay, or we can write like m bar is equal to sigma I modulus of ai square lambda I. നിങ്ങൾക്ക് ഇത് ഓർമ്മയുണ്ടായിരിക്കും. I have already explained this, why the modulus of ai square is equal to ai star ai. ഞാൻ കോംപ്ലക്സ് നമ്പേഴ്സിനെ നിങ്ങൾക്ക് പരിചയപ്പെടുത്തിയ സമയത്ത് ഇത് ഓൾറെഡി എക്സ്പ്ലെയിൻ ചെയ്തതാണ്. സോ യു ക്യാൻ ചെക്ക് ബാക്ക് മൈ പ്രീവിയസ് വീഡിയോ, വേർ യു വിൽ സീ ദാറ്റ് integral ai star ai is equal to square of modulus of ai. Okay, so M bar is equal to sigma I ai square lambda I. Now what is the meaning of this equation? What is the meaning of this equation? I will explain what is the meaning of this equation. Okay, you suppose that you are measuring, you are making 10 measurements. Okay, in 10 measurements, when you are making the 10 measurements of the property M, എമ്മിൻ്റെ 10 മെഷർമെൻറ്റ്സ് നിങ്ങൾ നടത്തുമ്പോൾ നിങ്ങൾക്ക് 10 തവണയും ഓരോ വാല്യൂസ് വെച്ച് കിട്ടും. ഫോർ എക്സാമ്പിൾ when you measured the property M for the first time, ഒന്നാമത്തെ തവണ നിങ്ങൾ മെഷർ ചെയ്ത സമയത്ത് you got the value lambda 1. Okay, when you measured it second time, you got the value as lambda 2. നിങ്ങൾ ഒരേ physical quantity ആണ് മെഷർ ചെയ്തത്, same physical quantity is being measured, but you are getting different values at different times. That is possible. For the same system can give different values for the physical quantity at a different time. അങ്ങനെ പോസിബിൾ ആണ്. ഇതിനെല്ലാം അലൗഡ് വാല്യൂസ് എന്നാണ് നമ്മൾ പറയുന്നത്. നമ്മൾ എനർജിയാണ് മെഷർ ചെയ്യുന്നതെങ്കിൽ യു ക്യാൻ മെഷർ എനർജി different values of energy at a different time. That is possible. So second time when you measured, you got the value lambda 2. Okay, you already know that lambda 2 is an eigenvalue of the m cap operator. So when you measured it third time, you got the value lambda 3. When you measured it for the fourth time, you got the value lambda 2 again. Okay, then when you measured it the fifth time, then you got the value lambda 2 again. And when you measured the sixth time, you got the value lambda 3. And when you measured it the seventh time measurement gave the value lambda 1. Okay, and eighth time measurement gave the value lambda 3. Okay, and ninth time measurement gave the value lambda 4. Okay, lambda 4. And 10th time measurement gave the value lambda 3 again. Say you have obtained 3 values for the physical quantity M. Which are these values? Lambda M, lambda 1, lambda 2, and lambda 3, and lambda 4. How many times did you get lambda 1? Lambda 1 എത്ര തവണ നിങ്ങൾക്ക് കിട്ടും? See, 1, 2, so only 2 times you got lambda 1. So lambda 1 you got 2 times. Out of 10, 2 times you got lambda 1. How many times did you get lambda 2? 1, 2, 3. So 3 times you got lambda 2. 3 times. And how many times did you get lambda 3? 1, 2, 3, and 4. Okay, so lambda 3 you got 4 times. Okay, out of 10. And how many times did you get a lambda 4? Only 1 time. So only one time you got lambda 4. Okay, so you made 10 measurements and you got 4 possible values, and out of that the first possible value lambda 1 was obtained 2 times, lambda 2 3 times, lambda 3 4 times, and lambda 4 1 time. Okay, so what is a fraction of lambda 1? Fraction of total number of measurements for which you got the lambda 1. Okay, the fraction of getting lambda 1, fraction of total number of times you got lambda 1 is 2 by 10. So if you are taking the fraction of total number of times, fraction of total number of times you get lambda 1, that is equal to 2 by 10, right? And a fraction of total number of times you get lambda 2, that is equal to 3 by 10. And fraction of total number of times you get lambda 3 is 4 by 10. And fraction of total number of times you get lambda 4 as the value you get is 1 divided by 10, right? So what is the average of all this? Okay, the average of all this is m bar is average. That is, you are measuring the physical quantity M, right? So the average of all this is equal to lambda 1 2 times, means 2 into lambda 1 plus 3 into lambda 2 plus 4 into lambda 3 plus 1 into 1 into lambda 4. Okay, divided by total number of times, that is 10. Or you can write it like m bar is equal to 2 by 10 lambda 1 plus 3 by 10 lambda 2 plus 4 by 10 lambda 3 plus 1 by 10 lambda 4. Okay, see what is 2 by 10? 2 by 10 is the fraction of times you get lambda 1. 3 by 10 is the fraction of number of times you get lambda 2. 4 by 10, fraction of number of times you get lambda 3. And 1 by 10 is the fraction of number of times you get lambda 4. So m bar is equal to this type. So, okay, now you can look at the equation that we already got. M bar is equal to sigma I ai square lambda I. Okay, sigma I ai square lambda I. So it means that that is a summation of different lambda i's multiplied with ai square. Okay, here also we have m bar is equal to is the summation of different lambda I. For example, lambda 1, lambda 2, lambda 3, lambda 4 multiplied with some constant, right? See, here lambda 1 is multiplied with 2 by 10, 3 by 10, 4 by 10 and 1 by 10. So if you take a1 is equal to root of if you take a1 square is equal to modulus of a1 square is equal to 2 by 10 and modulus of a2 square is equal to 3 by 10 and modulus of a3 square is equal to 4 by 10 and modulus of a4 square is equal to 1 by 10. You can write like m bar is equal to a1 square lambda 1 plus, instead of 3 by 10 you can write a2 square lambda 2 plus, instead of 4 by 10 you can write a3 square lambda 3 plus a4 square lambda 4, right? So in other words you can write sigma I is equal to 1 to 4 ai by ai square lambda I. You can write like this, right? So you have a similar equation. M bar is equal to sigma ai square lambda I. That is the equation what we have here. So taking this example, I just gave you a meaning of this equation. Okay. So what is meant by this equation? When you are measuring a physical quantity m, each time you will get some value lambda I. Each time you will get some value called lambda I. Okay, and in the coefficient of this lambda I, which is modulus of ai square, is the fraction of the total number of times you get lambda I. Okay, and the summation of all this will give you the average expectation value. Okay, or average expected value or expectation value. This is the meaning of this one. Now I hope you got what is the physical meaning of this equation. Okay, so the physical meaning is that you are measuring some physical quantity m, and each time when you measure you get some value lambda I. Okay, and how many times you get a lambda I, how many times you get a lambda I? If you know the total number of times, you get a ai square is ai square fraction of times you get a lambda I. Okay, so when you sum up all these things, you will get the expectation value. So from this one you can say what is sigma ai square. Sigma ai square is equal to എന്തായിരിക്കും? സിഗ്മ ai square is equal to എല്ലാ ഫ്രാക്ഷൻ്റെയും കൂടെ സം എന്ന് പറയുന്നത് എന്തായിരിക്കും? 1 ആയിരിക്കും, അല്ലേ? നിങ്ങൾ ആ എക്സാമ്പിളിലേക്ക് നോക്കിയാൽ മതി. നമ്മുടെ ai സ്ക്വയറുകൾ എന്തൊക്കെയായിരുന്നു? This was ai squares 2 by 10 plus 3 by 10 plus 4 by 10 plus 1 by 10. That is equal to 10 by 10, which is equal to 1. Okay, now I hope you got the meaning of this one. Okay, and now I will show you how we can use this fourth postulate in many calculations of the quantum mechanics. Just I am showing one step. For example, if you want to measure the expectation value of the position, okay, means you are observing some microscopic particle, okay, within a particular region, and each time when you are measuring the position you will get different measurements. So at the end you will see that, okay, in some particular region there is more possibility to find that particle. That is what you are going to obtain, okay, and that is what the you are going to that is what the information that you are going to obtain. So the average value of the position, okay, or average value of the expected position or expectation value of position x bar, okay, x bar is equal to integral minus infinity to plus infinity minus infinity to plus infinity psi star, okay. The position operator is multiplication operator x, then psi and dx, okay. So if you are looking at some particle moving in the x direction from minus infinity to plus infinity, the expectation value of that system is integral minus infinity to plus infinity psi star x psi dx. Okay, if you are looking at the at a system which is moving in the x direction only between two points, then you can change this lower limit and upper limit of this integral. Okay, then you have to give, for example, if the particle is moving from 0 to L, then you have to give integral 0 to L psi star x psi dx, like that. Okay. Similarly, if you want to get the expectation value of momentum, how you can get the expectation value of momentum? Px bar is equal to integral minus infinity to plus infinity. I just give minus infinity to plus infinity just because I have not mentioned the limit within which the particle is moving. That is why I gave minus infinity to plus infinity. Even if you already know the limit within which the particle is moving, then you can give the lower and upper limit. Okay, so integral minus infinity to plus infinity psi star, okay, psi star, and then m cap psi. What is m cap here? Okay, here our m cap is px cap, or momentum operator. Momentum operator is h divided by 2 pi I d by dx of psi, okay, dx, or we can write it like h divided by 2 pi I integral uh, minus infinity to plus infinity psi star d by dx psi dx. Okay, that is the expectation value of the momentum. So what is the expectation value of kinetic energy? Okay, you can measure the expectation value of kinetic energy. Tx bar is equal to integral minus infinity to plus infinity psi star. Now the operator is equal to minus h square divided by 8 pi square m d square by dx square of psi, right, of psi is dx. Okay, that is equal to minus h square divided by 8 pi square m integral minus infinity to plus infinity psi star d square psi by d square dx. Okay, so you can get the expectation value corresponding to different physical quantity from the fourth postulate. Okay, and you have to remember that the limit of integration in each case depends upon the total length available for the particles motion. Okay, and I hope you understood this many things. And as I always say, please keep your notebook with you, please. Otherwise, these things will look very easy, but at the end, you may not be able to write it in the examination. And write it many times, till you feel that this is your own stuff. Okay, so you should it should spontaneously flow your pen when you are sitting at the examination hall. In that way you have to practice it, otherwise it will be very confusing when you are already tensed. And so write it. That is the only way to learn quantum mechanics. Okay, and understand the concepts clearly. Okay, what is the physical meaning of each equation? All these things you have to understand. If you are stuck somewhere, and then pause the video, hear it once again, and try to understand, then you can call me or you can contact me by some other means. You can post your comments or doubts or comments here. Anyway, you can ask me the doubts. I hope you understood the lecture, and stay safe. And thank you for watching, and stay tuned.